half an hour, right? Okay, thank you. So I'll talk about beyond 4G communication, outlook for beyond 4G communication. So what I'll do, I'll talk about the current 4G technology and the 3GPP timeline, and what will beyond 4G communications look like. Talk a little bit about liquid radio concepts, which is an NSN coined term, and then briefly talk about conclusions. So the current 4G technology, what we know is LTE and LTE advanced. So as you can see in the chart here, the throughput is going up. So for LTE, it is more than 100. This is the peak rates here, by the way. And the latency is going down. So for LTE, it went from GSM 150 to 10 millisecond here. So there is a industry commitment behind this ecosystem. So there was a competing technology called WiMAX, and it didn't succeed because of there was no ecosystem behind it. So the 3GPP has the ecosystem. There will be more than 380 million LTE subscribers currently by 2015. There are 55 plus LTE networks expected to be commercial by end of 2012. And there are 113 LTE network operator commitments. Now, there's a technology convergence in LTE. So this WiMAX was mainly a TDD system or TD-LTE system. So where in LTE, it can support both FDD and TDD. And the baseband, there is a 90% harmonization. So the baseband, they're reusing both FDD and LTE has almost the same baseband structure. So it is a harmonized system, and it can support both TDD bands and LTE and FDD bands. And TDD is most popular in China, as well as in some parts of India. And there are operators here like Clearwire who are migrating from WiMAX to LTE currently. So there are 22 different LTE, the frequency bands. So there are a lot of frequency bands for FDD as well as for TDD. So there are 9 different TDD frequency band options. So that is the current state, very high spectral efficiency, throughput, low latency. That's what LTE is. So there are a lot of features or toolbox in an LTE system. So there is more bandwidth. So that is achieved by doing carrier aggregation. So LTE Release 8 can support a bandwidth up to 20 megahertz. LTE Advanced, you can carrier aggregate 520 megahertz band in the downlink and get up to 100 megahertz band. And with 100 megahertz and 8x8 MIMO, so LTE Advanced can support up to 8x8 MIMO in the downlink. And you can get a peak rate of 3 gigabits. Although this is a marketing perspective, because in an actual system, you'll never realize 8 gigabits, or you'll realize 8 gigabits if you're right in a direct line of sight of the antenna. Then there is cooperative system, cooperation. So it is, you can have cooperation. You can have COMP techniques like cooperative multi-point transmission. Relaying is a part of LTE advanced standards, but it has not taken off, because with relays, we don't see any capacity improvement. It is only will be used for enhancing coverage where there will be no coverage, right? So relays, and I'm talking in LTE, relays means it is in-band relays. So for in-band relays, the basic technique is your backhaul has to be really robust. The backhaul spectral efficiency has to be more than 5 bits per second per hertz for the relays to work, which is difficult to achieve. That's why in-band relays, although it is a cool technology, it never took off. The most important part, and this is where the next generation will go, is the concept of heterogeneous networks. So heterogeneous network is a collection of low power nodes. It can be picocells, it can be femtocells, it can be distributed antenna system. So that is where the technology is going. So you need heterogeneous network or small cells to get the user experience. That means it is like cell splitting. So if you go to small cells, you get the user experience of 5, 6 megabits at the cell edge, which cannot be achieved in a macro cell environment. So the future networks will be that the macro cell will provide the coverage, and the user experience will be provided by the small cells or heterogeneous network. So currently, the release 11, 3GPP is being completed. It will be completed by September, hopefully, between September to December timeframe. There is a release 12 workshop where the new technologies I will talk about will be presented, and the release 12 work will start sometime in September to November timeframe. So this shows the broadband is the fastest growing utility service. And you have seen this Cisco report, and by 2020, network needs to be ready with 1,000-fold traffic increase of mobile data traffic. And this is due to the proliferation of the smartphones. And so to support these smartphones, you need networks. And most of these use cases will be in a cluster formation where you will have to provide this user experience for users in a hotspot scenario, and where the pico cells or the small cells will be more attractive. So what will the world want from wireless beyond 2020? As we saw that there will be 1,000 times more traffic, rock-solid, ubiquitous connectivity. Now, the applications, so you need very high data rate to support very high data rate, and not the peak data rate, but across the whole cell. Because in 3GPP, we defined 3 metrics to define a system. One is the sector throughput. The second metric is the average user throughput. And the third metric is the 5 percentile cell user throughput, or the edge user throughput. That means the users at the cell edge, or 95% of the users, should have that experience. So you can see all these applications, 3D HD, Ultra HD, 3D HD TV, you have to support that. And then millisecond latency for the true local field. So you have to reduce the latency. Currently, we saw that the latency for LTE is around 10 milliseconds. So that has to be further reduced to get the local field. So this will all be achieved by using HetNet. That's why I'm emphasizing that we need small cells to meet the user experience demanded by extensive proliferation of smartphones and innovative applications. So we have to support various cell sizes at different frequency layers. So traditional macro and micro cell, metro and femto cells, as well as distributed antenna system. We have to support various radio access technologies because we have to support the legacy technologies also. And so we need to flexibly distribute traffic among RAT and layers. So, and an advanced self-organizing network. So if you look at the sites today, the majority of the cells it covers a larger area. The output power is 5 watts. So, and the share of sites are growing. So generally, it is for micro cells, it is around 100 to 300 meters with 1 to 5 watts of power. Then we'll have the picos and femtos in the third layer, where generally it is 1 watt or below. And then you will have the license exempt growing also, like Wi-Fi, and we'll have this Wi-Fi offloading scenario. And these are 10 to 100 meter mainly for indoors. So benefits of multi-layer deployment, coverage improvements from local area cells in edge or shadowed region, capacity increase for more transmission point in a given areas. So But it looks nice, but the problem is how to manage all these networks. So you need something like a self-organized network to manage this huge number of small cells. So one of the things why we need the small cells. So this is to illustrate that if you look, this is the macro cell user throughput. This is the average user throughput then there is this edge throughput, and then there is median user throughput. Now, if you look at this axis, and these are with no picocells, 1 picocells, 2 picocells, 4 picocells, and 10 picocells deployed per sector. Now, if you look at the macro cell UV throughput, that means user connected to the macro cell, you are getting around, say, 1 megabit average user throughput, and say around 500 kilobits edge user throughput. But when the users are connected to picocells, you are getting around 4 megabits, up to 6 megabits of user throughput. So you can see you can get a 5 to 6 times user experience improvement as the users are connected to the macro cell. And that is one of the rationales for going to small cells, so that you improve the user experience. The next is evolution. By 2020, there will be 10 times more spectrum available. You can see these are the unlicensed spectrum, 5 gigahertz and 2 in the gray. And if you go to 2020, there will be spectrum opening up at 3.7, 3.4, 2.6 is already open, 2.3, 2.1. So you can see there will be 10 times. It is spectrum below 6 gigahertz will be open. So the next question is that how to get more spectrum, because more spectrum means larger peak rates, better user experience. So why not look at millimeter wave bands? If you can see the millimeter wave bands, which is, I'm looking at, say, these are lightly licensed band, 721 to 76 gigahertz, 81 to 86 gigahertz. You can see that there is around 13 gigahertz of spectrum available. So why not utilize this spectrum? So, but millimeter wave bands has its own problems, but it has never been considered for access. It has been considered for backhaul operation, but not for access. So what we are looking at, how to use this band for access. So did a preliminary link budget, and we can see that you can support a 100-meter side-to-side distance. We can support peak data rates of 10 gigabits, cell data rate of 400 megabits. The slides I mentioned earlier, you can see the cell edge rates were around 3-4 megabits. Now, with millimeter wave, if you get to this kind of spectrum, 5 gigahertz of spectrum, you can support an edge data rate of 400 megabits. So you can get real user experience by going to these bands. This is an example of how the beyond 4G requirements will look like. So 10 gigabits of peak rate, around 0.5 gigabits of data rate, steady-only system, latency of less than 1 millisecond, and it will be supported using an integrated eNode B, which will support both access and backhaul. There are always implications associated with it, right? So high CNR implies small cells bringing the base station closer to the user. So at this band, the inter-side distance is 100 meters. So there will be more deployment of heterogeneous network of small cells when we go to this band. You can't deploy macro cells at this band. So you have to deploy small cells at this band. And there will be thousands and thousands of small cells. And how to manage all these small cells so you get a seamless experience, you have to have a self-organized network which will manage all these small cells. So there are a lot of issues on on the operational side of heterogeneous network, how to operate it. So on the spectral efficiency front, you can see that with LTE and LTE comp, I could achieve spectral efficiency close to 4. Now, the goal is to achieve spectral efficiency of close to 8. And how can we do that? So one of the reasons means a few years back they thought the radio was dead, all the radio technologies, because we have done turbo coding, which has reached the efficiency close to Shannon limit, whatever. Then we have used up to 64 QAM modulation, good for wireless network. Now what we are targeting is to go through an interference-free network. So we are putting in techniques, like in heterogeneous networks, you have co-channel deployments, you are putting in techniques where you mitigate the interference. And so the goal is to have a network where there is no intercell interference. And the millimeter wave is a good example of it, because in a millimeter wave system, the beams are narrow, so the interference between the adjacent cells will be minimized. So the global base station forecast is number of cellular base stations grows over 50 million. 80% will be macro cell or micro cell or smaller. Additionally, there will be 500 million Wi-Fi access points. So the global base station forecast will move by 10 times more. So if you look at, we are targeting to 1,000x capacity, which will be achieved using 10x performance, 10x spectrum requirements, 10x base stations. So that's how we'll achieve 1,000x capacity in a beyond 4G system. Now, in the release 12-13 time space, so we are looking at, these are the performance enhancements, small cell deployments, local area optimization. So in release 11, in release 12-13, we are looking at advanced UE receivers, new carrier type. Now, new carrier types means carrier which is more efficient in terms of overhead. So we are reducing the number of overheads in a new carrier type. And then there is this enhanced PDCCH, or the enhanced control channel. That means the control channel currently cannot do beamforming in LTE. But when you go to LTE Advanced, that's what we are doing, enhanced PDCCH, which can do control beamforming. And this whole thing is based on dedicated reference signal rather than common reference signal. Multi-antenna schemes, we are exploiting the elevation direction. So currently, we exploit the azimuth only. So why not exploit the elevation direction also? So in that case, this will be mainly deployed in a macro cell, but if you exploit the elevation direction, you can control the interference to the picocell. Small cell deployment, this is, as I talked about, and local area optimizations. Why not do enhancement specific for local area with increased capacity, new physical layer features, energy efficiency, and device-to-device communication. And so device-to-device communication is one of the aspects being proposed in Release 12. So this mentioned requirement will most likely lead to a mix of solutions. So as I said, it will have UE-specific elevation beamforming and very large antenna arrays. Coordinated multi-point transmission. Now, this coordinated multi-point transmission, it is both for downlink and uplink. What we saw for downlink is that you don't get any advantage in sector throughput, but you improve the edge throughput with coordinated multi-point transmission by around 30%. So that has a simple version will be standardized in Release 11. There is this new carrier aggregation and new carrier type. So this is a very important step where you are doing this carrier, which will operate in association with a legacy carrier, and it can also be operated in Release 12 as a standalone carrier. Innovative spectrum usage and sharing concept, I'll talk briefly about ASA, or authorized shared access, and then there is more spectrum and new bands. And of course, there is more base stations with head nets. Requirements of future mobile communication. So there is exponential growth in data demand, more diverse services like machine-to-machine cloud computing, and strongly reduced cost per bit and energy per bit. There is a mix of solution as we talked about. And the future system, we are densifying the network, that is dense heterogeneous deployment, multitude of transceiver scheme, including multi-cell coordination, elevation beamforming, and multitude ways to use the spectrum, including direct device-to-device communication and millimeter wave. And the key challenges for operating such a system, as I talked about, is interference management, mobility and session management, and network infrastructure. So the motivation for 3D MIMO, there is this, we have deployed sector-specific vertical beamforming, and now we are going towards, so this will probably a proposal in release 12 where we are doing UE-specific vertical beamforming. So we are extending MIMO and beamforming techniques to exploit two-dimensional array configuration. So adapt in both azimuth and elevation dimensions simultaneously. New carrier type, as I told you, it is a new carrier which is used to eliminate legacy control signaling and common reference signals. I'll not go through the details, but the motivation is enhanced spectral efficiency, reduced energy consumption, and better support for heterogeneous network. There is some elements of cognitive radio which will be proposed in release 12. I don't know whether it will be introduced or not. It is called authorized shared access, which targets globally harmonized spectrum available for LTE. Okay. So if you look at this figure, so you have the individual authorization, then you have a licensed shared use, and then you have the authorized shared access. So ASA is a new and complementary way of authorizing spectrum use in addition to exclusive licensing scheme as we have now. So ASA spectrum is not necessarily available all the time in every location. ASA spectrum may need to be evacuated when requested by the primary user. And there is a ASA server which will control this use of the spectrum. Now coming to the liquid radio effect, I'll skip this slide. So capacity demand is this is a cool slide, like a wave in modem networks. So the capacity demand is not, it is fluid. That's what the liquid radio is. So it varies with the time of the day, right? Because if you have a hotspot, it will not be a hotspot throughout the day. At night, there'll be no traffic in that area. So why not take advantage of that? Instead of designing base station to serve a capacity, constant capacity, why not have a system where you can trunk the capacity to the other base station? Now, how can you do that? So I'll mainly talk about today the liquid radio aspects, and there's a liquid core also. So using these three concepts of baseband pooling, active antenna system, unified, and SON-enabled heterogeneous network, these are the key element of liquid radio. So you can have this baseband pooling scheme. You can have this baseband pooling so you can get this trunking gain. So, and if you do baseband pooling, you can direct your capacity where it is needed. Then we'll have an active antenna system I talked about with beamforming, UE-specific beamforming and comp, and then we'll have an unified and SON-enabled heterogeneous network. Nothing new here. So the architecture of baseband processing is that you can have a on-site integration, so you can have 3 sectors, and the baseband will be common. It will be pooled over there. You can have a multi-technology with extendable capacity, so can host medium number of cells, including remote radio head, small cells, and true single RAN solution. So this is the site-level pooling. Then the cluster-level pooling. So if you have a macro cell with 3 sectors and say 12 picos underlay within that sector, you can have a cluster level pooling. So you have fiber connected to all these remote radio heads, and the baseband is pooled at a central location. And the grand vision is you have this network level pooling where you have out of site integration. So how can we deploy, commission, and maintain all the radios, frequency bands, and layer? It sounds simple on the paper, but this is the most challenging problem you have. All cells and frequency layers automatically managed by advanced self-organizing networks. All spectrum under unified RRM and instant capacity and coverage optimization. Cognitive radios like authorized shared spectrum will reduce errors, improve quality, and lower operation energy costs. So you have all these technologies, TD-LTE, LTE Advanced, LTE, GSM, HSPA+, TD-LTE, FM to Wi-Fi. So, and there is all this spectrum available. So you have multiple radio access technologies, RAT. You have multiple spectrum. You have all these base stations, PICO, femtos, distributed area, antenna system. All these things has to work effectively using this SON, and it will be managed by this SON network. So finally, gigabit experience, reliable, efficient, and personal. The goal is ubiquitous connectivity, which is achieved using unified radio resource management and cognitive networks, using features like active antennas or 3D beamforming, liquid radio, wideband multi-radio. And the main goal is to have multi-carrier, multi-standard, heterogeneous network, and self-organized network. So this is the vision or the outlook for beyond 4G system, which will be a collection of low-power nodes distributed across the system. And the main goal is to how to manage all these radio access technologies, all this spectrum, and all these millions of nodes. And that can be achieved using this self-organized network. That's all I have, and thank you. Any questions now? Yes. Yeah, the question was, what is the potential of LT femtocells competing with Wi-Fi? What we think is that both Wi-Fi and LTE are complementary technologies. Now, with LTE femtocells, there are all these issues that whether we want to open up the femtocells to all the users or you want to restrict it to certain users. And then there is all these problems of interference management with femtocells. But I think Wi-Fi and femtocells will be deployed in a complementary way, where femtocells will use the backhaul networks already at home. So it is, I'll say at this point, it will be a complementary technologies. Next.
I just have one question on the resource pooling for the baseband processing and others. So how does that, in terms of maximum tolerable delay and latency?
Yeah, so the question was that with baseband pooling, how you can tolerate the delay. Currently, with baseband pooling, the only application is that you are connected by means of CPRI links, which has very low delay. And the baseband pooling will never occur with wireless backhaul. It has to be a CPRI link or gigabit Ethernet. So that's my answer. Next question. I missed your question. So it is single frequency, what?
Single frequency
Full duplex. Now the FDD is a full duplex thing, right? Yes. And mainly the local area networks, the one I talked about, say 60 gigahertz, those are mainly TDD systems, right? So what I think it will happen, you will have both FDD and TDD supported. And in LTE, what I said, the FDD and TDD system are both integrated, and there is not much difference between them in terms of the baseband processing. So I'm not very knowledgeable on what you are asking, so I have to get back to you on that. Any other questions? Yes. I'm not familiar. You see, in terms of signal processing and digital communication, I don't think there will be changes to what we have. Like we'll have OFDMA, we have single carriers, cyclic prefix, single carrier modulation. You'll not enhance the spectral efficiency by changing the multiple access techniques. It will not happen. The multiple access techniques, OFDMA or CDMA or what we have, those are the optimal what we have achieved. There's not much there. The main invention will come on how to reduce the interference in a multiple access system. That's where the invention is. The more invention comes where how the heterogeneous networks will operate, small cells. That's what the invention is. Not what kind of model means. You can go with 256 QAM, but in a cellular system, you will not have the SNR to support 256 QAM in an outdoor environment. You see. So in terms of coding, what can you do? You see, you have turbo coding. Means you can gain another 0.5, 0.6 dB, but that will not give you the bulk of the improvement, right? So I think the area which has opened up in digital communication is this area of heterogeneous network, and there are still lot of things to be invented there. Lot of things to be invented in different frequency bands like millimeter wave, you see. But in terms of classical digital communication, it is very difficult to make improvements.
Yeah, I know there's a lot of interest. I apologize, but since Tara showed me with the clock, I have to keep time from now on. So we're now going to move from an equipment developing company to the other extreme of the spectrum, wireless spectrum, the ultimate service provider. And our next speaker is Chris Nasinger. Chris graduated from Washington State University, and over the last 20 years, he has held many leadership positions in a variety of wireless application areas, both technical and on the business side. He is now an executive director of network deployment at Verizon, and over there he's in charge of both the network architecture and delivery of applications. So, and he's going to talk about application awareness, wireless networks. Thank you, Chris.
So how do I go to the next slide?
That's a question. It's right here.
Got it. Okay. Well, I want to thank you for inviting me. My lawyers make me talk about this slide first before I talk about anything. So if anybody comes back and says, did I give a safe harbor speech? Yes. So Verizon's a publicly traded company, so anything I say here is not a commitment that we're going to do these things. So, done. Okay. Here's the outline of my talk. It's going to be very similar to what we just saw. I'll talk a little bit about industry trends and a need for additional technologies, but then I'm going to focus a little bit on an intelligent content delivery for wireless. So there's, you know, as mentioned before, no silver bullet of a 5G technology that's going to increase the efficiency of the network 1,000 times. There's also, from a business perspective, even if we can increase the capacity 1,000 times so that people will use 1,000 times more, no one's going to pay 1,000 times more. So we have a business problem. We'll get into that a little bit and then go through a quick summary. So here's a background check for us. I mean, we all know this, that over the last decade or two, the shift from fixed telephony to mobile telephony has been pretty dramatic. You know, I was in the industry in wireless when I remember when our revenue went to 5% of the revenue of the phone company, and we were no longer classified as other revenue in the revenue statement. And that wasn't that long ago. And I remember how the wireless companies said, yeah, we finally made it to the point where we're relevant on the P&L statement of our legacy phone company, to the point now where, you know, we're almost the only thing that's important. So there's been a dramatic change there. And the same thing's happened already with broadband as well. Broadband, again, started out all fixed, and there's been a big push towards more and more